Hello everyone, welcome to our today's session. As you know, on our last week's session we have seen what are algorithms, or we have seen a number of ideas regarding an algorithms, especially the algorithms that we will deal with the course of this structure. But now we will try to see properties of an algorithms. What properties does these algorithms have? Would be our today's session. And then now to give you a kind of clue on our last week's session on algorithms are what they are solutions of a problem. We can call them the solutions, by the way, the solutions. Or we can explain them. These are the steps of procedures that we use to solve the problem that we have. Assume we may have a number of problems. For example, you can take an example of a problem which deals with computing summation of three numbers. For example, let's say this is a problem that we have. Then how we can solve this one? It needs a number of steps. That combination of steps was named the algorithm. For example, we have to take the data that we need to compute their summation, and then after we will compute after having the data, we will try to compute the summation of all of these three numbers. Then finally we will try to display the result to the users or to the persons who need to use it. Then this is a combination of procedures or a set of procedures. Then this is what we call a solution, or we can call it an algorithm. Then having said that, what are the properties of these algorithms? And here we have listed a number of properties of them. The first one was finite. Then as you already know, algorithms are finite in number. Then that's obvious. They have a finite number of steps. They start, then they will take a kind of data. For example, for the problem that we have seen before, or in this case, for the problem of calculating the summation of three numbers, we have to start. The algorithm must be start. Then it will take the numbers either from the keyboard or in a statical manner. Then after checking the numbers of these three elements, then it will try to perform the process, which is calculating the summation of these three numbers. Then finally the summation will be deployed, will be displayed to the users who need it. Then here you can relate that there are a finite number of steps. Then this characteristics of the algorithms was named as finite. Then in short we can call them algorithms are finite. The other one, sequence. In this one, algorithms have a sequence. They start, they will take a number, then they will try to find summation, for example, for the problem that we have seen before. Then finally they will try to display the result to the users. Then this is a combination of sequences, or they have a sequences. Then that character of the algorithm was named as a sequence. And the other one, they must be feasible, or they have a property of feasibility. They must perform each instructions in a feasible manner. The other property, like correctness, the algorithms must be correct for all of the legal inputs. That's already obvious. For example, when we deal with calculating the summation of three numbers, the algorithm must compute the summation of these three numbers in a correct manner. That must not work to some data, but not to the other data. If the algorithm that you have developed have such kind of characters, we never call it that is That's not an algorithm. That's a biased algorithm. Then for all the legal inputs, the algorithms that we have developed must produce the correct result. That's why we will call it they must be correct. Then the other issue, the other purpose of algorithms deals language independence. In language independence in this case, that's already familiar with this one or you know it. When we develop an algorithm, we can develop using any language in college, in universities, in TVT programs. We may develop algorithms using in English texts, but that was because of the medium of communication. When we have the right to develop using local language, we can. In Amharic or in other language, we can develop them. But beyond this one, in total, it doesn't have any interference on their implementation. We can develop the algorithms in any programming language, using any programming language, using either C#, Java, C++, Python. It depends. So they don't have any effect on the programming language. Then we can develop an algorithm using any programming, using any language. That's why we call them they are language independent. The other property of an algorithms have completeness. As you already know, the algorithm that we have been developing for a problem must solve the problem completely, unless that was not a correct algorithm. Then the other properties of an algorithm are this one. There must be an effectiveness and efficiency. Then with respect to this property, especially with the property of efficiency, the algorithms that we have been developing must be an efficient. This one, time and resource complexity of the algorithms was very important parameter to make to judge algorithms whether they are best algorithms or not. Then our algorithms must take a limited resources of these elements with respect to time and memory requirements. The algorithms must be the most important matters. Then at her expectation or to the highest level, we have to make them. Our algorithms must demand less time and space complexity requirements. This one. Then generality, as you all know, our algorithms must be general. You already know that. The algorithm should be valid on all possible inputs. Then that indicates a kind of generality property. They must be general. The other purpose of an algorithm deals with input and output. An algorithms have an input and they must generate at least one or more outputs. Then in general, as we have seen before, the problem of computing summation of three numbers, they must generate their summation. That's the output of this one, and taking the values of the three numbers was the input of that algorithm. Then these are the most important elements. So in general, algorithms have an input and they must display an output to the reader. So this is the other attributes or the other purpose of the algorithms, which have having seen this one. Some individuals might be confused with algorithms versus the second term named the programs. Already, as we have seen on our last sessions, including on our today's session, algorithms are a well-defined solutions. By the way, they are step-by-step procedures that we can use to solve the problem that we have. For example, calculating the summation of these three numbers, as we have seen on our last week, on the above, on the start of our today's session. So these are solutions, but they are not programs, by the way. Algorithms were not programs. Whereas the programs are, they are codes. When we say program or an instruction, it refers to the code which is written by any programmer using a number of programming languages. So we can use them Java, C++, C Sharp, Python. These are a kind of programming language, especially we can call them, we always call them high-level programming language. Then these are a kind of programming language that we can use to develop the programs. The programs are instructions by the way. Then algorithms are the solutions, but the programs are codes. They are codes which are written by using any programming language like that of Java, C++, C Sharp, Python, and C. So this is the difference between algorithm and program. Already we can develop an algorithm of any problem using either of the pseudocode or the flowcharts. You already know the flowcharts will use geometrical shapes, whereas the pseudocode will use a kind of human language. That's why natural language, we call it natural language, using a kind of sentence like statements. Then this is what we have on our today's session. Then if you have any question, suggestions, and additional ideas, you can put on the coming session. Thank you so much.